Welcome back to the channel, everyone. I know it's feeling a bit rough out there, stormy seas, but today I want to talk about industry trends, two massive waves of innovation that are headed our way. One is related to this revolution of sky compute, and the other is associated with edge AI and edge compute generally. This is going to be a really long, in-depth video breaking down new emerging products from other companies that are pushing, innovation in this space. We're going to cover the execution risk with Palantir and what I see as a rising competitor, and also questioning if their leadership is in place. But one thing is for sure: when these waves converge, it is going to have the force of an atomic bomb. So get ready, people. All right, so let's start with a quick State of the Union. What I'm demonstrating here is a tool called React Query, and it's a tool that's used a lot today to build web applications in this technology called React, which is it is by far the most popular technology used to build apps. I think like 80% of web apps are built with React. Anyway, what happens when you attempt to interact with a web application is that it communicates to a server to modify or otherwise change data, or what we call the state of an application. And when you do this, it sends a network request out that includes, which we call an XHR request. And XHR was invented back in the early 2000s as sort of a way to get around traditional form-based approaches for submitting data to a server, where your URL in the browser would have to change every time you want to manipulate some data. And so here I'm going to add a to-do, and what it's going to do is it's going to send one of these XHR requests out to a server on the back end. And in a minute, you'll see where I expand and kind of show you what that request looks like. And by the way, I'm using Chrome DevTools here. So you can see there's a request URL there. That's the location of the server, the method that's being executed against it. I get a status code back, but more importantly, it sends along all these request headers. Those are the response headers from the server. The request headers are beneath it. And that includes like all the information the server needs in order to process your request, right? Now, in a modern architecture, there isn't just like one service out there. There's what we call a service mesh, which is made up of potentially hundreds of microservices, right? And we use a central gateway like GraphQL to funnel all these web application requests in and hide the complexity of that underlying service mesh. So, and it's really important to note that this is a really hard problem in a lot of cases. Service orchestration of microservices, just to do simple things like change the state of an application, mutate some data. There is a huge amount of engineering work that goes into it. And so what we're going to explore is some ways around that. And towards the end of this video, we'll explore new architectures that enable that. But there are new companies out there that are specializing in building platforms that allow you to build these modern architectures that get around microservice orchestration problems, get around the complexity of deploying those to the cloud, move you away from REST-based services like you just saw demonstrated here, and into binary socket servers as one potential solution. And also change the location of this entire stack that's running right now. So as you can see, like, you essentially get the front end of an application, while the back end, all the services and microservices, those are all running in some cloud provider somewhere. This wave of edge compute and edge AI is going to change that. We really need to move the compute closer to where the data is generated, which means your laptop, your phone, your computer, it's all got to get sort of distributed out there. And one of the companies that's working on this problem is called StackBlitz. And StackBlitz makes online interactive development environments for software engineers. And they're one of the leading, I believe they are the leading provider of that type of solution. I believe they're the only company that sort of has the right compute model that's out there, which sort of, it runs the compute closer to your browser, and the stuff that happens on the server is pretty minimal, meaning that, a lot of the interactivity has to be built into the the tool that sits in your browser layer. And this is going to be kind of a common theme. More and more application logic is going to have to be runnable closer to your browser, and that's sort of been the trend over the past several years. But we're even going to go a step further. So this gateway I was showing you here, where I'm sending a request to the server and getting a response back, what if I was able to take that gateway and move it over to your browser to where I didn't need to actually send a network request out to AWS or out to some other location where I'm running a microservice? I could actually manage that request directly in your browser. Well, that's what StackBlitz is working on through this technology called web containers. They found a way to take the most popular runtime out there for building these things, Node.js, and run it natively in your browser using a technology called WebAssembly. What that has enabled is for us to move this entire layer of compute completely out of the AWS infrastructure and have you run it on your browser, running on your laptop, running on your phone, running wherever. And this is incredibly creative because they can compile the runtime. They can provide a layer of security in there, so we can do things like data validation when you submit a request. We can do things like routing directly in the browser as opposed to having to do it in an API gateway in a server. We could also do things like direct database connectivity, or we could do things like connect to a binary socket server. And that is really cool because binary socket server connection running out of WASM is like, I actually think that's probably one of the better use cases for WASM right now. I believe Unity kind of does that under the hood as well. Like for the game plumbing framework, we're analyzing what Unity is producing. And it looks like it produces something that along those lines where there's a WASM library that handles the encoding of the binary data that goes out to the socket. And with the game plumbing framework, they found a way to make that scalable. So imagine you're not building web applications anymore in a traditional client server paradigm, or there's still kind of like that paradigm, but you're not using REST, you're using serialization of the data into the WASM library in the form of probably JSON. Then the WASM library encodes it into a binary protocol that goes out to some socket server, which can then stream those updates out to another platform. And we'll go over that architecture at the end of this video. It's what I believe will bring Foundry into the nexus of all these things and provide a solution for scalability out of Foundry for the actual messaging that's taking place between the client applications and the underlying Foundry layer where the data is being stored. And so anyway, this is a really cool technology. I encourage you all to kind of learn about StackBlitz web containers. But one of the cool things about it is that their AWS bill is like $200 a month and they have millions of users. So why do we care about edge compute? Why does it matter? It fucking matters because we don't have to pay massive compute bills anymore. And that infrastructure, oddly enough, is more stable. So it's like, in a way, in some ways, it makes the app even more stable than it would be if it was running in AWS or something. Another technology. This is serverless cloud. This is a new evolution of the serverless framework that abstracts away all of the infrastructure as code you used to have to write in the YAML files. So like when you would deploy a serverless infrastructure traditionally, you'd have to define how that thing was going to run in AWS. And they gave you some syntax sugar that sat on top of the CloudFormation templates to make that much easier. But serverless cloud provisions that infrastructure directly from your code. Right, so like you can write semantic meaning about how you just write the code in a meaningful way to them, and they can figure out by looking at your code and analyzing your code exactly how it should be deployed on AWS. Another platform that's really pushing this concept of sky compute is Vercel, and Vercel makes building entire React applications dead simple. Like I don't have to write any infrastructure as code. I can just write the React app and Vercel will automatically deploy that and even optimize the code to run on edge networks. And they have integrations for like Shopify and Fauna. Fauna is an awesome database as a service technology that you don't even have to worry about database connectivity or launching databases on AWS. And of course you have like Shopify for e-commerce. So like I can write this code and just never think about provisioning any of these services, directly integrate them into my app, and get edge network optimization if I deploy my app through Vercel. So this is another company that's thinking about like, hey, what does the future of application development look like when I stop worrying about the cloud? Here's another one, Vendia. Vendia was created by Tim Wagner, who created AWS Lambda. He was also the former VP of technology at Coinbase, and Tim's a total visionary. But he's really created this thing called Vendia Share, which is like basically a distributed database technology. And he's found a way to merge the best of central IT, these sort of central databases, with private blockchain and public blockchain technology. And so Vendia Share is this really cool distributed database technology that also gives you some guarantees that you would traditionally get from a blockchain. And so Tim is a visionary. I encourage you to really check this out. This is another example of like, I don't worry about any of the infrastructure code. There is no infrastructure code. I just write application code and they provision the infrastructure for me, manage it for me, and they provision it directly from my code, right? So really cool technology, really cool vendor, coming up with some great solutions. But I think the downside here is that all of these solutions I've showed you so far, they create data silos still. It's still yet another data silo. And I don't see Vendia Share actually powering the decision making that my VP of product needs to make, or that my chief marketing officer needs to make. Like, so I think that on some level these solutions are awesome, but they're not solving the data fabric problem, and that's really what Foundry solves. Here's another really cool technology, temporal. I love temporal. I want to see temporal integrated into Foundry. I might even start working on something like that fairly soon as part of the game plumbing framework stuff. But really what's cool about temporal is they make all of the hard parts of mutation. So let's say I wanted to do a really cool architecture called CQRS. This stands for Command Query Responsibility Segregation. And CQRS is really cool because it allows you to make really, really fast, efficient reads. It allows you to handle state mutation in a really elegant and clean way. And temporal can make that entire architecture like extremely easy, something a junior engineer could put together. You can write you essentially work in a Turing complete language like Go or TypeScript, but you can write time-dependent transaction logic that recurs, for recurring payments, for example, or credit card processing, or travel reservations. You can implement any kind of transaction or state mutation in a way that's guaranteed to succeed or fail. And even if the server goes down, even if temporal completely crashes, they guarantee that they can bring that thing back up and pick up where it left off. So that is a massive innovation, in my opinion, and something that big players are looking at and using already today. Hats off to all the folks at Temporal, and I will be integrating this technology ASAP. So this is just yet another example, though, of like taking hard problems for developers that are really hard today and making them easy and doing all the infrastructure management directly from the code. And it's so cool as a developer. You're just actually writing business value, business logic, things that are actually delivering value to your users. And you're not thinking about any of the underlying complexity. So y'all starting to see the general trend here. It's about removing complexity, making things simple. If you've watched my previous videos, why does that matter? The famous quote from Rich Hickey. All right, so next up, NX Cloud. NX Cloud is an awesome, awesome tool. NX is a monorepo management tool, which means it allows you to organize and manage and deploy changes to massive amounts of code. A monorepo is a single location where all of your organization's code is stored across multiple technologies. And NX makes that easy to manage, easy to build, easy to deploy. And NX Cloud is this amazing technology. The guys who created Angular over at Google created this. They left Google to form NX, and they wrote NX Cloud. And basically what they do is they anticipate what you're going to need for a distributed build system and cache it effectively. So they can, like, because their tool is integrated into your code base, they can essentially analyze and figure out a really smart plan to build it the fastest way possible and how they can cache that and then deploy it. And this is another one that is allowing me to take advantage of a really complicated problem, distributed compute across a build system. That's a fucking hard problem. And they make it dead simple, right? So like, I don't even have to think about it. I one command, I got up and running with this tool, and it makes my builds like 10 times faster. And they're using a global compute infrastructure to do that. They abstract all of that complexity away. They do all the parallelization. They figure out all of the ways to optimize all of those steps so that the serial steps happen serially, the parallel steps happen in parallel, and you never think about it, right? Really, really cool technology. I encourage you to check them out. I've had the pleasure of working with these people. I met Jeffrey Cross a while back, and we did some consulting work, or had his company do some consulting work for us. Fantastic company, fantastic technology. If you're in the technology space, you really got to check this out, in my opinion. And then next up, I think we're going to take a look here at Zeta. And Zeta is like a serverless database. Well, what does that mean? It's really like they have a database technology that you don't need to think about or worry about where it runs. And you can just write applications that work directly on top of it. And you can use, again, just normal code that looks just like any other code. I don't have to like write, special infrastructure as code or deal with the problems related to the services on AWS. All I'm writing is like a really, really expressive database interaction. and it can work seamlessly with my React apps and or seamlessly with my web applications with really really low latency, which means I can do like really cool data grids that don't have that don't have the appearance from a code point of view of having to deal with all of the interaction with the service mesh. Just makes it dead simple for me to write code that just works, that just mutates data, integrated with their database solution. So I think this is really cool from a developer point of view, like things we want to see as part of application frameworks, right? So like uh, this is just another one of these solutions. But again, it's yet another data silo. It's not the data fabric of the org. It's not integrated into the decision making process that the actual organization decision makers need to be making. It's just yet another data silo. The data's got to be like, this is application data basically. It's app data. This is the app data layer. All these solutions are just providing app data layers. But how does that get into the data fabric of the org? Well, that's where shit gets complicated. That's where like all of the problems related to service orchestration, et cetera, come into play. And that's where I believe Foundry is going to really, solve the most amount of issues and be front and center, the industry leader for this. So I forgot a couple mentions that I want to bring up here because they're really important for this concept of sky compute and how we're pushing workloads to the edge. Fly.io, you can run any kind of container-based workflow at the edge, which is really cool. They have a global edge network in which you can run container-based workloads, and King's distributed systems, which really allows you to take advantage if you're in the ML AI space at university of really, really powerful instances for research purposes that where you can run any workload on sort of idle compute that's sitting in university research labs and in other environments. You can even you can also do hybrid cloud models. They do have an edge computing model. So this is another innovative, really cool company that's taking advantage of this, both the edge AI push and the push for sky compute. So as you're starting to see now, there are a lot of companies working on new architectures, new ways of writing code, new ways of generating infrastructure from code, new ways of distributing jobs like King's distributed systems for ML and AI research, all of which abstract away all of the details of the underlying cloud provider. This is the common theme here, people. Developers and researchers do not want to have to worry about the plumbing of where their apps and research are running, okay? It's just a waste of time. It doesn't allow shit to get done. You spend more time orchestrating things and building infrastructure than actually doing valuable research and development. Okay, so this is the common theme of why the industry is moving this way. So there is a huge push too. This is not a small revolution. This is a big revolution. Palantir is at the nexus of all these things, and we'll get into that as to why. We're going to talk about it and how Palantir fits into all this, how Foundry fits in, how Apollo fits in, and sort of why I believe they can win. But then we're going to talk about the execution risk, okay? Because like a lot of people right now aren't considering the execution risk as it relates to Palantir. And we're going to talk about that as well. All right. All right, so let's talk execution risk on Palantir, and let's frame it in the context of VMware's Cloud Foundation product. VMware's Cloud Foundation product is a solution for container-based workloads that lets you take advantage of hybrid cloud models, on-prem models, just like Apollo, right? And they sell it as a platform for multi-cloud and modern apps, which it most certainly is. The difference is in the execution and probably some underlying product details in which I think Palantir is more appropriately positioned, for example, for dealing with edge AI problems, deploying out to private secure networks, deploying out to devices, right? So like not just cloud infrastructure, but also like how do I get a software system onto a satellite or onto embedded systems, right? So like Palantir has probably a more unique advantage there, and the technology seems a little bit more advanced maybe. But without a direct comparison, I can't make that statement. VMware has got some fucking amazing engineers, people. So like let's not kid ourselves. Like VMware is an excellent, excellent technology company. They've been thought leaders for a long time. So what is different here? Well, I can try this product, right? I have a hands-on lab I can go try it with, right? There's cost calculators. There's this is available through AWS, GCP. It's available directly through VMware as a hosted service, fully accessible. The documentation's available, and it's not cheap, right? So like this isn't going to be a cheap solution. If you think this isn't going to be comparable to Palantir pricing, you're out of your damn mind. Like, yeah, enterprise software is expensive. This shit is very expensive, but the TAM for this is massive. It's like Every workload in the near future, for all the reasons I've laid out in this video, is going to be running this stuff. You're not going to have old school, I'm using the cloud service provider, I'm using Circle CI, I'm using fucking Jenkins, whatever it is. No, we need a platform that's meant to run applications anywhere. VMware does that and Apollo does that. But the difference here is that I can actually access this thing, and it was a well thought out execution strategy. It makes sense to me as an engineer and as a stakeholder for my organization, as someone who's going to put their reputation on the line for the product. It's presented in such a way that it's easy for me to make that argument. All that is execution. The only difference here is execution. Now, if the reason Palantir hasn't created their own cloud yet is that they don't think that's a viable strategy, they're wrong. And you need to put new leadership in place to change that decision. If the reason it's that they haven't done this yet is that their products aren't ready, my opinion of that is that that's an all hands on deck moment, and you need to solve that problem within a quarter or two. You do not have years to solve that problem. The reason is that people like me will start moving to adopt VMware instead of Apollo if that's the case. Like no matter what, people like me are expected to put the pieces in place to build the future foundations for the business. We don't have time to wait on Palantir for that. So that's a massive execution risk. I want us all to be aware of it. I'm not saying that that's the case. I'm just saying that like these are the hypotheticals as an investor you need to walk yourself through to realize like, are they actually executing? And if they're not executing, why not? And maybe their software's not all the way there yet and they're not ready. I don't know that, but it could be a reason. Or maybe they don't like the same strategy because they're sensitive to PR and maybe they can't have their platform be as open because of their government work. I'm not sure. If those are the reasons, those are solvable problems, and it should be all hands on deck. Let's get this thing, solid. Let's open it up. We got to get beyond the risk, what we're worried about from a PR perspective or whatever. Those are solvable problems. But if it's the executive leadership doesn't believe that this type of go-to-market strategy is the right one necessarily, that there's a better one if we're a closed platform, we're somehow playing on Peter Thiel's 0 to 1 foundational concept, like, bro, I got nothing to say other than that leadership needs to be exited and you need to put in better leadership. That's my opinion. I could be wrong about that. And I hope I'm wrong about that. I don't think that that's the case. I think that there's probably some level of engineering work that needs to go into getting this stuff ready. I don't know that though. But in any case, like it's probably something along those lines. But whatever it is, we as investors all need to remember the risk we have. And in my mind, the biggest risk is the execution, their go-to-market strategy, how they're positioning the product, how they're selling the product. That's the big risk, okay? And so as an investor, that's what I'm sort of monitoring. And if you watch my like thesis breakers on Palantir, you can kind of see that reflected when I'm talking about customer count and developer community. Those are the metrics that I'm going to track to determine how well they execute. And if they can, I believe, like this is my opinion, if they don't substantially move the needle this year, they're going to be behind the 8 ball chasing people like VMware. They're not going to be the leader anymore. They're going to be caught behind a trend that they should have been leading, right? And they've done this before. Remember, Alex Karp said that in that shareholders call, these people who are selling all these products, these thin clients as these thin solutions, we were building stuff like that 7 years ago. Well, that's an admission, in my opinion, that you fucked up. That you were the leaders and didn't lead the way. You had the solutions and didn't know how to monetize them or bring them to market effectively. So they've done this before. They've tripped over their own 2 feet before. But as Karp said, they won't do that again. And I'm trusting them. I believe them. I believe in their leadership. I think they're the level of talent, the level of just strategy, being able to think about things and really formulate a strategy and bring it together. I think their leadership is definitely top notch in that area. But it's what I'm looking at. I'm looking at the execution and I'm measuring it in terms of customer count. I'm measuring it in terms of developer community. Those are part of my thesis breakers for Palantir. And I don't believe they have an infinite timeline. I think it's 2022. You get that shit together or you're going to be caught behind the 8 ball and you're going to fail to execute it again. That's me talking based on everyone in the industry I'm talking to who are trying to actively solve these problems and lay a foundation and for a technology roadmap that takes us out the next 5 years. You do not have a long time, so figure it out. All right, people, let's talk architecture and what I see as sort of what I want to build on Foundry, which is being realized through this Foundry for Gaming proof of concept and through the use of the game plumbing framework. I believe that the true insight of Amon and Daniel, who created the game plumbing framework, was that we need a better way to communicate between a web application or a game and the underlying server. And that the true authoritative thing in that loop really needs to be the server, right? The data should be driven through the server, and it should the client should be reactive to that data and kept in sync, right? And it's a multi-tenant kind of thing. You have multiple players in a game. You have people who use every web application today. Really expect that multiple people can use that app at the same time. And so we are going to get rid of rest there, and we're going to move to binary sockets, and we're going to leverage different technologies like WebAssembly to make that happen. And we're going to build this. Like, I'm working on it right now, and right there is the game plumbing framework. Right, that's the server objects in the game plumbing framework. We plan to augment them with some sort of Kafka data stream or similar technology. And what will end up happening is, as you're a user of a web app or a mobile app or a game that's built on this technology, when you're mutating data or changing the state of the world, as we call it, it'll send that into a Kafka stream, and all of this will be managed, by the way, through Apollo. So this proxy and passive pub sub notification service you see here, that's all going to be managed by Apollo, deploying it out to hopefully the edge. Now, one day, maybe we can actually get this to run at edge, because really, there's nothing stateful in the system if you think about it, okay? The statefulness, the management, the transaction processing, that's all going to be below the Foundry system boundary. And so when you try to mutate something, let's say I'm going to pay for something, right? And in my app here, I have a form you're filling out to do a, say, credit card payment. That's going to go into the state of the world here, which is the proxy, which is the server object that's handling that transaction. It will optimistically process it, submit the state into processing. That'll go into a Kafka data stream. And within that Kafka data stream, eventually it'll make its way over to a Foundry API. So Foundry has a native integration to this technology, Kafka, which is basically an ordered set of events. If the best way to think about data streaming is like, it's an ordered set of events where you want to process each one. And you can process them in batch, you can process them in parallel. There's lots of different ways you can process these things. You can trigger other downstream services and other types of events, like what we call a fan out strategy. So you can like fan out the streams. But for the simplicity purpose, let's just imagine it's a credit card payment. It's going to make its way into the Foundry API. That API will handle the actual processing. Or not, the API won't. The API is just, sorry, the actual Foundry API is a way to get that event out of the stream and send it into Foundry for data processing. And what we're going to do there is set this up as to be managed through the ontology's actions, right? So if you saw, I don't know if you've seen the videos yet from Logan over at Palantir, but I believe he's working on a video that will demonstrate ontology actions for you. But within the ontology, I can create an object and I can define a behavior for that object, which we call an action. So for the ontology API, it will take this incoming credit card processing event and process it as an action on top of, like, say, a subscription ontology object. And what that will do, in my opinion, is under the hood, I want to program that to work with temporal. So I'll have temporal running in my Foundry layer as a sidecar deployment in my infrastructure, again managed through Apollo. And it will do the details of resolving that action into either succeeds or it fails. Temporal is excellent at doing this. It can set up the recurring payment process part, and I can communicate directly from my action to that service, right? Once that's done, it'll update the state of, say, my subscription. And once it updates the state of the subscription, I want to trigger a write back through phonograph. This is the value of the write back notification, right? So, and the other beauty of this taking place in the ontology layer, not just having the write back capability and the action capability, is now I can mutate the data fabric of my organization, the actual data model that informs the decision makers and empowers the AI development. It's all my apps are now integrated into that data fabric. It's not yet another data silo, right? This isn't just another data silo of app layers sitting out there on AWS somewhere, on GCP or wherever. This is the actual data fabric of my entire organization. I'm keeping up to speed with the data stream now, right? And once we hit phonograph for write back notification, I might dump it into a data set. I might dump it into an ERP system. But in my proof of concept, I'm going to dump it to a data set, and I'm going to trigger a passive pub sub notification back to my proxy so the state of the world can be updated. And that'll tell my proxy, hey, your credit card transaction either succeeded or failed, right? And that'll let the proxy know through the server objects and game plumbing framework. We'll let the client update. right, to whatever the state of that transaction is. This means, now let's talk, why does this matter, okay? Wow, that seems complicated, right? Like, if you're an engineer out there, you're just probably going, dude, that's the most complicated bunch of bullshit I've ever heard in my life. The reason it matters is I want everything in my organization to move at the speed of the data stream. I can't do that today with yet another data silo, and I never will be able to. That's why Foundry matters. And Foundry also matters because the reason I want to do that is I want non-technical people to make data-driven decisions at the speed the events are happening. Only Foundry can provide that platform. The other reason it matters is that all of this up here, like if you really look at it, is completely 100% stateless. Like I could actually run this on the edge. I don't need to run it in VMs. What's the downside of using virtual machines and that approach? The traditional downside, or the downside that I typically see, is A, the cost, and B, it doesn't really get into how you could properly leverage the underlying compute. Okay, so like let's back up a little bit. There is internally at AWS, you will hear things from like their CTO, who says that he believes that serverless is the way we should all be building applications. Why does he say that? Because the underlying compute model for these micro VMs, these micro containers that are running under there, that is way more efficient for them. That is way more scalable for them to take advantage of the overall compute infrastructure than what we call virtual machines, which is typically what we're deploying through technologies like Kubernetes. All right, so like just this matters because I can use what is called isolates, which are essentially these little micro stateless VMs that are way, way, way more scalable. And I can also move this entire thing out to your browser. So not only can I take advantage of the compute that's out there from a cloud provider in a way more cost-effective, way more scalable way, I can push this whole thing out to the client if I wanted to. I could run the game plumbing framework server part in a container in WebAssembly, and all of the communication, everything here is happening in your browser. I'm not paying for that compute anymore. That's like going from paying for like, a $2 million kind of yearly compute to like $200 or $2,000. So like that's also why it matters. That's why the architectures are changing, is that like, why can't I just run all of this server crap sitting out somewhere on the client device or closer to where the client is, rather than having to build all that infrastructure, host it myself, So there's a lot of opportunity in here too for business development. Like if you think of just this part as being a standalone business, you'd be thinking correctly, right? That's a SaaS platform in and of itself to build the future of web applications and of games. If you look at the layers down here, this is the future of business, period, So there's a lot of room to develop independent companies that specialize in these things, but and this is a proof of concept architecture, people. It's what we call a napkin sketch. Like this isn't real, okay? We have to validate all of these things. Each component needs to be the architecture of each component would have to be validated and fleshed out. But in the early sort of research we've done together, I see no reason we can't make some version of this actually work and build massive value on, like starting tomorrow. This is why Palantir and Foundry and Apollo are at the nexus of all of this movement, right? It is the platform, the premier platform to both make data-driven decisions, aggregate and analyze all the data that's going to be spit out of these systems. It provides the deployment mechanism through Apollo to manage all of this at scale across what they call a homogeneous compute layer, which I call Sky Compute, which is basically the global compute infrastructure, including your devices, okay? Many companies aren't considering that use case of needing to deploy to the actual device. And Palantir is leading, in my opinion, there. Like they're deploying satellites in a very novel, very unique way. You should read about the satellite deployment they did with the DoD on that satellite that I believe they're using it to track submarine movements and ship movements and stuff like that. But like, check that out. It's very unique, and that's why they're at the nexus of all this. They're the only company in my mind that was forward thinking enough to know about all of these things and kind of where the industry was going to go. And they, as a result, it has informed some very good product decision making, some very good design decisions. However, their execution has not been good to date, in my opinion. And we talked about that. I don't want to get sidetracked, but this type of architecture is going to be the Foundry for gaming concept. When we are done, we will present this to the world as an alternative way to build applications that is better, that lets you take full advantage of the edge, full advantage of the client compute, and all of the goodness in Foundry while providing, and the other good thing about this architecture is this can scale horizontally forever. This piece up here, that scales horizontally forever. It takes the workload out of Foundry. Foundry doesn't have to keep up with the volume of that data. Your throttle is the Kafka stream. How much data you choose to read out of that stream, which determines your system latency, that's your throttle, right? And so Foundry, then you can keep your workloads sane. Foundry is a big system. It's over 100 it's hundreds of microservices. I don't know how many exactly. It's hundreds of microservices. You don't want to scale that thing out to match the volume of data being generated here. You need a throttle to let that data come in, which determines your overall system latency. The good thing is that 90% of the time, what we call an optimistic update strategy, meaning the client and the proxy here, the state of the world, can just be updated, even though things haven't actually been written out in Foundry and processed. It's still good enough for us to just assume they will be handled that way. And then later on, if I get a notification that it failed, I can take remediation. I can build a remediation strategy that sends that information back to the client. But this is a great architecture, man, and it's going to let us get the best of all worlds, and I believe could empower us to build the future of web applications on it. And I think it will provide a future architecture that everyone will want as like sort of the de facto standard to actually build, the future of software on. And even more important, the same architecture could actually power edge AI and model serving. A server object could also be created for models and edge AI. Like, that's fucking awesome. That basically takes the protocol of interacting with the model and codifies it into a server object, and then clients can just work with it. That's another fucking awesome application of this technology. And that can be truly stateless if you don't need the inferences tracked in Foundry. I would say still want the inference audit trail in Foundry, and that's what you would use this for, so that you have a full audit trail of how the model came to that conclusion. That's really useful in almost any application, right? And it's kind of what we see already. If you're doing self-driving, autonomous self-driving, you're doing equipment failure monitoring or anything where AI is being used today, they're using some flavor of this type of an architecture in order to push that model out. And it's usually the proxy and the client, they're all on the same device. And it's usually embedded. But so anyway, this is just another example that this is an extremely flexible, extremely powerful technology. And the true genius behind Aman and Daniel's creation is that at some level, they had this sort of transcendent idea that we need better ways to make a server authoritative communication system. And dude, when I learned that, like, it just blew my mind. I was like, oh, this needs to be combined with Foundry, like, immediately, for all of the reasons that we've talked about, including the data analytics space, first party ownership of your data, a better way to do client server communication. Like, all these things are sort of like coming together. And so at the end of the day, why it matters, why Palantir is at the center of all of this with Apollo and Foundry, is that they really have the only all-in-one platform solution to make architectures like this possible and to provide the tools to move at the speed of the data stream. So there you have it, people. My case for why Palantir, why Foundry, why Apollo are just going to be at the nexus of this next evolution of software. And it's my opinion that this will transform the landscape. It's going to be beneficial, in my opinion, for cloud providers. They can cut bait with all the services they're stuck maintaining now that are essentially directly competing with real innovators in those spaces. And they can focus on compute and infrastructure. And it's a win-win, and it lets companies like VMware and Palantir focus on leveraging that global compute infrastructure and providing the software and the services that deliver the business value, right? And so I think that at the end of the day, Palantir could be transformative. I mean, this company, the TAM is just undefinable. The level of things it's going to affect down to like video games, is crazy. But the risk is the execution. So I hope you all got something from this video. I hope you understand where things are going and gave a better idea maybe of where my philosophy for Palantir is at. And to not stress on every competitor you see. There's going to be competition. This is the future. It's not just everyone who's a forward-thinking engineer knows it. And so just understand that there will be competition, but it's all about execution. It's all about the quality of the product. All right, so I'll see you next time.